Paper airplanes have been a staple of childhood entertainment for generations, but have you ever wondered what makes them fly? It all comes down to aerodynamics, the study of air movement around objects. When a paper airplane is thrown through the air, it creates a thin layer of turbulent air behind it. This turbulent air can be either pushed or pulled towards the plane, depending on its shape and angle of attack. The curved upper surface of the wing pushes the air downwards, creating an area of lower air pressure above the wing and higher air pressure below. The paper airplane's flat bottom surface acts like a flap, helping to control its stability and balance in flight. As it cuts through the air, the plane creates a vortex of air around itself, which can either lift or drag the plane depending on the angle at which it meets the ground. The smooth motion of a well-made paper airplane is an incredible example of how carefully designed shapes can harness the power of air. Paper airplanes have been studied extensively by engineers and aerodynamics experts who have found that they share many similarities with real aircraft. From their wing curves to their rudder-like tails, paper planes are essentially miniature replicas of full-sized planes. One key difference between a well-made paper airplane and a functional aircraft is its weight distribution. Paper airplanes typically weigh very little, so the tiny forces acting upon them can have huge effects on flight. This means that even slight imperfections in the plane's design or construction can significantly impact its performance. For example, if the wing of a paper airplane is slightly curved upwards at one end, it will be pushed towards the ground, creating turbulence and drag. Conversely, a perfectly flat wing would produce much smoother air flow. The same principle applies to the tail section of the plane. A straighter edge will create more stability. Despite their simplicity, paper airplanes have been used in some surprising ways throughout history. For instance, during World War II, German engineers created a paper airplane called the Zeppelin, which could travel impressive distances while carrying tiny payloads. In modern times, researchers are using computer simulations and model testing to better understand how paper airplanes fly. By analyzing various angles and wing configurations, scientists aim to develop new designs for even more efficient aircraft like those that can carry people instead of just paper. So next time you fold a paper airplane, remember the incredible science behind its flight, from its curved wings to its precise tail balances.